This is the question asked in today's skillrack daily challenge. So we are given an integer n as input, and after that we are given an array of n integers as input, and then we are given an integer k as input. So here k is equal to 3. So we have to flip the last third bit for every integer x among the given n integers. So first let us write down all the binary representation for the given integers. So for the integer 10, the binary representation is 1010, and for the integer 31, this is the binary representation, and for the integer 3, the binary representation is 11, and for 16, the binary representation is 1, after that 4 zeros. So now our task is to flip the last third bit for every binary representation, because here the value of k is equal to 3. Suppose if it is 4, then we have to flip the last fourth bit, but here we have to flip the last third bit. So for this integer, after flipping the last third bit, the binary representation will be modified like this, because the last third bit is 0. So from 0 it has been changed to 1. Similarly, for the next integer, again we have to toggle the last third bit. So the last third bit is here, so it is 1, so it should be changed to 0. And then for the next integer, we have only 2 bits, so we don't have the last third bit at all. So in these cases we can keep it as such. So after modifying also it will be 1 1 only. And then for the last integer, it has 5 bits, so we can flip the last third bit. So after flipping the last third bit, this is how the modified binary representation will be looking like. So I am changing the last third bit to 1. So now our task is to find the decimal values of these updated binary values. So for 1110, the decimal value will be 14, and then for the next binary representation, the new decimal value will be 27, and for the third integer, the new decimal value is 3, and for last integer, the new decimal value is 20. So now our task is to add all these new integers and print it in our output. So here 27 plus 3 is 30, and then 30 plus 20 is 50, and then plus 14 is 64. So the sum of all the integers is 64. So in our output also we can see that we are getting 64. So this is how we are getting 64 as our output. Now let us see how to write a C program for this. So in the main function, first I am creating 3 integer variables n, k and sum, and initially I am setting sum is equal to 0, and in the next line I am using a scanf, I am accepting the integer n as input, and then I am creating an integer array ARR of size n. So now we have to accept n integers and store it into ARR. So you have to create a for loop and we have to store it into the array ARR, and after that we have to accept the integer k as input. So now we have to iterate through each and every integer present in the array ARR, and for every integer we have to flip its kth bit from the end, and after flipping its kth bit we have to find its new decimal value, and we have to add that decimal value with the integer variable sum. So we have to do this for all the integers, and after the execution of the loop we have to print the sum. So our task is to now see how this function flip k works. So in the arguments we are passing the integer from the array and we are passing the integer k. So now let us see how we will be implementing it. So this is the code for the function flip k. So in the arguments I am accepting the integer n and the integer k. So for the integer n we have to flip its kth bit from the last. So in order to perform this, first I am creating 2 more integer variables named bitnum and output. So we will be using this integer variable output in order to find the new decimal value after flipping the kth bit. So our new decimal value will be stored in this integer output, and we will be using this bitnum function in order to at which bit we are currently present at. So now in order to iterate through bits, we will be creating a while loop. So we should iterate until n becomes equal to 0, and in every iteration we have to divide the integer n by 2, and n mod 2 is nothing but the bit. So I am storing this n mod 2 in an integer variable named bit. So now in every iteration we will be iterating through a bit, so we should also increment this variable named bitnum. So I'm incrementing bitnum, so bitnum plus plus. So it is given in the question that we have to flip only the kth bit from the last. So actually in this process we are actually iterating through the bits from the end only. So we have to check whether it is the last kth bit or not. So here using if condition we are checking whether the bit num is equal to k minus 1. Here we are checking whether it is equal to k minus 1 because we are starting the bit num from 0. So that is why if bit num is equal to k minus 1, then that is the kth bit from the last. So whenever this condition is true, we have to toggle the bit. So we know the current bit which is stored in this integer variable bit. So now whenever this if condition is satisfied, if that bit is equal to 1, then we should make it to 0. If it is equal to 0, then we should make it to 1. So like this we have to toggle their values. So that is what we should be doing whenever bit num is equal to k minus 1. So after modifying the bit, instead of storing it into a new integer and then finding the decimal value, simultaneously we can calculate the decimal value. So whenever bit is equal to 1, we can just find the value of 2 power bit num and we can add it with the integer variable output. So for example, let us assume a binary 110. So now if we need to find the decimal value of this binary, what we will be doing is from the end, wherever it is 1, we will raise 2 to the bit number. So the decimal value of this particular binary representation is nothing but 2 power 1 plus 2 power 2. So when we find the result of this expression, that will be the decimal value. So 2 power 2 is 4 and 2 power 1 is 2. So 4 plus 2 is equal to 6. So the decimal value of this binary expression 110 is 6. So this is how basically we will find the decimal value. So whenever the bit is equal to 1, we will be finding the 2 power the bit number and we will add it with the integer variable. So that is what we are doing here also. So whenever the bit is equal to 1, then we have to calculate 2 power bit number and we have to add that value with the output. So here we have to write a condition such a way that output plus is equal to power of 2 comma bit number. So when we are going to execute a condition like this, simultaneously while we are iterating through the bits, we will calculate the new decimal value also. So finally after the execution of this while loop, we would have modified the kth bit and we would have also find the new integer value that is formed after modifying the last kth bit. So we have to return that integer which is stored in the output, and after returning it in the output in the main function, we will add it with the sum and we will print the total sum. So this is the logic to solve today's daily challenge. Thank you for watching.